So far, all of the games that we have studied are 2 by 2 games, meaning two players, each of which have two strategies. In this lesson, we're going to start considering larger games. In our first example, there is a dispute between Florida and Mississippi over offshore drilling rights in the Gulf of Mexico. It is an election year, and both parties have called simultaneous news conferences to announce their positions on the dispute. The leaders of both parties calculate what they think will happen under certain pairs of strategies and arrive at the following matrix, whose payoffs are the percentage of the vote that will go to the Republicans. What is each party's best strategy? So first of all, the reason that the percentages of the vote will go to the Republicans is because I made the Republicans the role player. In a zero-sum game, such as the ones we've been studying so far, the payoffs in the matrix are always payoffs to the role player. Had I made the Democrats the role player, then the entries in the matrix would be the percentage of the vote that would go to the Democrats. So the first step in solving a game is to check for a saddle point. And we do that by finding first the row minima. What is the smallest number in row 1? 40%. The smallest number in row 2 out of 60, 55, and 50 is 50%. And the smallest number in row 3 out of 45, 55, and 40% is 40%. Those are the worst case scenario for the Republicans. The fundamental idea of game theory is to look at the worst case scenarios and then choose the best. The best of these would be the one that has the greatest percentage of vote for the Republicans. That's the maximum of the row minima, or what we call the maxi-min. So out of 40%, 50%, and 40%, the biggest, the maxi-min, is 50%. Now we're going to look at it from the point of view of the column player and find the column maxima. Remember, in a zero-sum game, the column player likes small numbers, so his worst-case scenario would be large numbers. The largest numbers in column 1 out of 45, 60, and 45 would be 60%. In column 2, the largest number out of 50, 55, and 55 would be 55%. And in column 3, the largest number out of 40, 50, and 40%, the largest is 50%. The best of the worst case scenario, remembering that the column player likes small numbers, would be the smallest of these. The smallest of the maxima is called the minimax. And the smallest out of 60, 55%, and 50% is 50%. Notice in this game, the maxi-min and the mini-max are the same. That means we have a saddle point. Our saddle point is this 50% that is in the third column and the second row. When you have a saddle point, it means that the optimal strategy for each player is a pure strategy, not a mixed strategy. Meaning every time the game is played, they should do the same thing. Well, let's now answer the question. What is each party's best strategy? The Republicans should always do the same thing. What is that same thing? Well, since the saddle point is in row 2 and the row 2 strategy is to take Mississippi's side, the Republicans should always take Mississippi's side. And what should the Democrats always do? Well, the Democrats are the column player, and our saddle point of 50% is in column 3. So the Democrats should always remain neutral. And we're done. In our next example, we'll look at what happens when you have a larger than 2 by 2 game and there is no saddle point.